Hello, let's talk about the character controller in the Wicked Engine. If you have the Wicked Engine editor open, you can open a character controller demo script that is located in content/scripts/character controller folder, and it's called the character controller.lua. You can simply open it in the editor with the open button or pressing the play button if you didn't have any previously executed script. If you have, like me, then the play button will list in the tooltip which script was executed last, and now it says for me that it was the character controller.lua. So if I click the play button, then this script will be run. Once the script is loaded, you will see something like this. You have a character that you can control, and there are several other characters moving about in a simple scene. You can rotate the camera by pressing the right mouse button and rotate it around the character. You can use the WASD keys to move the character about. And there is a simple explanation of the controls in this floating text that you can read. You can also control this with a connected controller if you want. You can also talk to these non-player characters by moving in front of them and pressing Enter key. Then a conversation will happen, which will also offer you some choices that you can experiment with. You can also create your own conversations if you want. You can change characters in this script. I will show you how. And you can change the level in this script. And you can also change other things like character positioning and such. You can also modify the script completely by creating new controls or things like that. If you press the escape, then you will be returned to the editor if you opened this script from the Wicked Engine editor. Just to demonstrate, I will now demonstrate that the play button now reopens this script and starts it from scratch. And you can also press the R button to reload the script. This is useful if you modify the Lua script and want to quickly test the changes by reloading it. Now I will show you how to modify character and how to modify the level for this script, so you can create your own little character controllers. Exit the script, and for now exit the editor. What I have open right now is the character controller Lua script in the Visual Studio Code application. I navigated to kind of the bottom of this file where you can see load model functions and character and creating characters with for the player and the NPCs, and also loading animations. For this script, it is really easy to load a new character or a new level, and it will use some existing animations to remap to your new characters that you loaded. You can simply create new characters in the Vroid Studio application, which is a separate application which lets you export VRM character models. VRM is sort of like a GLTF model, but with slight modifications. It lets you use several extensions like expressions, character humanoid rig with predefined limbs and such, and also colliders and some procedural animations like simple physics-based hair and cloth animation. You can create a new character in the Vroid Studio application that I have open right now. There are 3 sample characters. You can choose one, for example, Avatar A. Once the character has been loaded into Vroid Studio, then you can modify it pretty easily by creating new hairstyles, body types and outfits, and also accessories for the character. Okay, say that let's choose this outfit just to modify our character a little bit. And now, after you completed the modifications, you can export it with this button in the top right corner. You choose as export as VRM. You can configure some settings for the export, but just let's leave it as it is now and just export it. I just leave the avatar name and parameters as they are. Simply export it to some location as a.vrm. Once the exporting is complete, just navigate to your saved character. I reopen the Wicked Engine editor. I can just simply, you can choose the open button and open this file, or I can also drag and drop into the editor. So the character has been opened in the editor. As you can see, it has the name a.vrm, and it also looks towards your mouse position. This is possible because the VRM model creates a humanoid skeleton, and it has some additional properties and logic that the engine uses, like looking at a point of interest, which is configured to be the mouse position inside the editor. If you select the VRM model entity, you can see new component types that you probably haven't seen before with other kinds of models: humanoid component and an expression component. In the humanoid component, you can see bone mappings. If you select a bone, then the skeleton will also be displayed, and in the skeleton you see two different things. Blue bones are just regular bones. Pink bones are bones that are configured for spring physics, which is a simplified animation kind. It's mainly used for simple hair physics and cloth physics, like the skirt. If you grab the model and move it, you can see some movement in the skirt. In the humanoid component, you can also enable or disable character following the mouse. If you disable follow the mouse, then it will keep looking at the direction it was looking previously. If you disable look at, then it will face the default orientation. You can also tweak some other settings, like, for example, head size and such, if you wish. You can also control head movement limits, and also the same for the eyes. Those take effect when the character is looking at something, how far the head can be turned. For now, let's disable the look at. Now let's see the expression component. The expression component contains something such as an automatic blinking animation. The blinking is an expression, and there are also several other expressions, like, for example, emotions like anger, fun, joy, and such. These are automatically exported for every character by Vroid Studio. You can select an emotion by just selecting it, and you can increase the weight of the emotion to check out the result instantly. These can also be controlled by scripts, so they are very, very useful in a character conversation, for example. The VRM character also contains colliders. You can see the colliders by applying a filter and filter the colliders with these little capsule icons. If you select a collider, then you will see all the colliders highlighted in these with these purple debug lines. These sphere colliders are used to collide the hair springs and the cloth springs, so that the procedural animation or the procedural simple physics does not collide with the character itself, but it keeps some distance with the help of these colliders. The colliders can also be used to collide with particle systems and other colliders, or also scripts. You can use them in scripts to collide with anything you want. These colliders are not physics colliders, so they are not using the physics engine. They are used only for these simplistic physics like particle systems and your own scripts and collider versus collider checks. Okay, now let's see how you can put this character into your character controller script. First, let's save this character as a WI scene file. So Ctrl-Shift-S, or just press the save button and save this to the character controller location. Within that, the assets folder contains assets that are loadable by the script file. I just recommend you put the assets into the assets folder to keep it more organized. So let's save this as a.wi scene. Overwrite this. Once it's saved, go back to the character controller Lua script, and where the player is loaded here in this line, player equals character, then the character asset file is character.wi scene. I can just rename it to a.vscene, a.wi scene, which is our newly exported model. Save this script, go back to the editor, and press the play button to reopen the character controller script. And now the animations are mapped to our new character, and you can control this character as expected with all the controls and all the features that were previously available. Now the weird thing is that I had the colliders selected in the editor, so the collider visualizers are still visualized, but that's not a huge problem right now. So you can check out this level with your new character. As you can see, the collider of the character, which this big capsule collider was not visible in the editor because that's not actually part of the model file. This is created by the script itself. So you don't need to perform additional character setup tasks like specifying specifying a big capsule collider for the character. This is set up automatically for you by the character controller Lua script. That's just a side note. Okay, now let's say that you want to load a new level to play in with your character. Exit the script now. I also close the editor for now. I will not actually want to load all the other NPC characters in our new level, just because just to show that you can also like disable these NPCs pretty easily. Just comment them all out. Keep the NPC stable because that might be referenced at other points of the script. But if this table is empty, that will just mean that no NPC characters are loaded. As you can see a couple lines above, below the clear world command, which clears the scene, load model calls level.wiscene. The level is that simple level that is used by default on the character controller script. Let's say I just want to create a new level that I will want to modify the script by. Okay, open the editor again. Let's say create a level from scratch. That's just a really simple level. I will add the plane. Press 3 to scale it up. This will be our ground. I'll add a few boxes or cubes. Okay, this will be our level. Pretty simple, right? Oh, let's also add the directional light, so it's not too weird. Rotate it a bit. I will also enable shadows. So this will be our new level. The character controller script expects that any geometry that you want to walk on or be blocked by should be enabled as a navigation mesh. You can select an object or select all objects with Ctrl.A, and with the object panel, just check this checkbox nav mesh. Now when you select different objects, that you notice that every object was selected for nav mesh. And for now, nav mesh does just simply means that it's a filter for intersection checks, so that these objects will be detected when the character intersection code is running. I will save this scene now, Ctrl-Shift-S, and within the character controller assets folder, I will save it as simple.wiscene. Once it's saved, I go back to the character controller script and rewrite the level.wiscene with simple.wiscene. Save it, go back to the editor. You could delete the scene or just play or actually I will delete the scene just to see that you don't have to keep it opened. The character controller script will just open this when you start to execute it. So press the play button again, and you are dropped into your new scene. And you can collide with the navigation meshes as expected. If you have complex scene geometry, for example, high poly model for a scene, then I would recommend not using everything as a navigation mesh, because using the high polygon models as collision objects, just it will just slow down. It can slow down the character controller code. I recommend to build low polygon meshes and use those as navigation meshes. I will demonstrate what I mean. Exit this script. You can select, for example, the ground mesh. Let's say that you have a really high polygon mesh here, but you don't want to use that. Instead, you want to use a low poly navigation mesh here. Okay, let's reopen actually only this simple.wiscene that we saved right now. Drag it into the editor. It's opened. Just this, so we will save just this little scene. And then you want to have a high poly visual model and a low poly nav mesh model on top of it. You create the low poly nav mesh model, you can just uncheck renderable, and it won't be rendered. Only your high poly visual model will be rendered instead. And once I save this model, and rerun the script, then you see I don't have to have a visually anything here. It's enough if there is a mesh and it's tagged as nav mesh. It doesn't need to be renderable. It can be just used like this. Let's exit it. Let's return to our original demo level. Just undo this change and save it as the level.wi scene that you want to run in the character controller. Return to the editor, rerun it. Oh, and also re-enable the NPCs. So uncomment these, save it. I press R, so the script will be reloaded. Now we just demonstrate some other features of this. For example, as you can see, there are multiple NPCs that are patrolling the area. You can set up patrol locations within the script by placing waypoints into the scene in the editor, naming them with something, and you can just, at the bottom of this script, the patrol waypoints are specified here. So it just looks up entities by name, and those are transforms. So the array of the kind of you can specify kind of tables of waypoints for every NPC. What kind of which waypoints are do they want to patrol? How much do they wait on those when they reach the waypoint? And other things like what kind of states they enter. So for example, this NPC 2 will enter the state jog for this waypoint, and it doesn't wait anything, it just keeps running, and it actually waits for 2 seconds at waypoint 5. It's a little cumbersome right now, but with this way you can specify these patrol waypoints. And if you don't specify any patrol waypoints, the NPC will just stand in place. Another feature is that you can have moving platforms. These platforms are controlled by animation system. You can create these simple animations in the editor too. And the character can stand on top of these. You can also jump onto any object tagged with navigation mesh. One cool feature also for these characters is that they have inverse kinematics in their feet. So if you stand on some uneven ground, then the feet will be placed accordingly to the ground. You also don't have to specify anything for this, because for these type of VRM characters, this will just work automatically out of the box. This logic is also created by this script file, by the way. What else? If there is any grass in the scene, which is created by hair particle systems, the character capsule collider, which you can, by the way, also check by pressing the H button. It will display some debug information, like collision points for the character and colliders. The collider also pushes away grass particles, which creates a nice effect. If you place any water material meshes, any meshes with water material applied to them, then the character will automatically swim inside them if certain point is reached. It looks like there is some kind of bug right now with the swimming. Okay, but the point is that the character will automatically swim once it reaches a certain water depth. these colored physics cubes are using the physics engine. The character collision itself is not using the physics engine, but these are using it, which is actually not true right now, it seems. Oh no, I remember. So with the default character, you have to actually specify a physics engine collider for a character. Let's return to the script and undo. Let's check the original character just to show what I mean. Return to the script, reload it with the R button. Okay, so the original character can push away these colored boxes with the physics engine. I will demonstrate why. Let's exit this script. Let's close everything. Inside the script asset folder, the character.wi scene is the default character used by the script. Let's open it in the editor. If I select this character, you can see that there is a rigid body attached to it. You can visualize the physics entities by moving to the general window and selecting the physics visualizer. Then you can see the bullet physics shape, which is this capsule, which kind of matches our capsule created by the character controller script code. But right now the physics collider is not created by the script code. This is something you will have to specify yourself and save into the character right now, which might change in the future. This physics collider, if you check it in the component window, rigid body physics component window, you can see that this is tagged with kinematic. This means that this will not drive any physics simulation for itself, but it will act as an animated entity within the physics system. Since this is attached to the character, it will follow the character and just push away any physics entities that it comes in contact with. Let's disable the physics visualizer and return to the character controller script. One other thing that I want to show is that when the character moves about, it leaves behind these footprints. These are decals, and there can be an infinite number of them. So I think it's like after 100 decals have been placed that it will start removing older ones. But the point is that these are decals. If you exit the script with the ask button, you will see it in the editor, a bunch of decals placed into the scene. These are placed automatically by the character controller script. You can modify the decal texture if you want. If you want to modify, if you want to customize this script, you can disable them entirely as well by going to the script, navigating to the top. After searching for decals, I came to the conclusion that you can't disable them very easily right now, but you can, for example, cap the max number of decals to 0, which you can just do here. This perhaps will be improved in the future. Return to the script, rerun the script, and then since I limited them to 0, I'm no longer placing any footprint decals, but this is not the most elegant way to solve it. One last thing, that this kind of debug text in the character controller is not placed into the scene model file. This is also created entirely inside the script by just placing some debug text within the Lua code. This you can search for by just searching for this text. For example, search for controls, and you arrive to this section of the code. If you want to modify it, let's say that I want to, I don't know, write hello world here, just delete everything in this string. Just enter hello world, save the script, return to the character controller, press R button to reload it. And then it says hello world. You could also just write it here. Reload the script. Okay, so now it's only saying hello world. With this script, you can also zoom in and out the camera. There is also some limits to the camera movement that you can configure if you just dig a bit deeper into the script. So it limits kind of how far you can move the camera up or down, and how close you can move the camera to the character. And there is actually no limit on how far you can move the camera away from the character. Okay, I think that's it for the character controller script. I hope you found it interesting, and give it a go, see what you can come up with by modifying this script and playing around with the settings and new characters and new levels. Stay tuned for more videos. See you.